Hi everyone, it's me, Wei Qiang here again. I have gotten requests from parents asking me to work on some questions that involve the topic of volume. And I remember that I once mentioned that one of the questions that I shared and discussed about was not exactly an ideal question. Today I will discuss this question, which I took from my um, stash of worksheets, and we find that this is actually a better question to be asking and to be testing the students on. So anyway, here we go. The whole idea of this question is that the water from here, from tank A, is being poured, which is full. Sorry, tank A is currently full with water, full of water, and the water from tank A is actually being poured into tank B. So there will be a point in time whereby the height of the water is the same. However, the base area is different. We have 40 on one side, 30 here, 45 here, and 40 here. It is good to note that there's 40 and a 40 here. Okay, when we're dealing with volume questions, we want to encourage our children to be flexible in their thinking and to be able to imagine these containers and be able to rotate them around. Over here, we have a common length, okay, which is 40 cm here and 40 cm here, which we will make use of in a while. So to start off, we got to find the volume of the water in tank A. Okay, so it's actually 40 cm multiplied 30 multiplied 60 is actually 72,000 cubic centimeters. Then we talk about the base area of A. Okay, base area, okay, of tank A is actually 40 multiplied 30 will be 1,200. The base area of tank B is actually 40 multiplied 45 is actually 1,800. Now, it is, as I mentioned earlier, it is important for our children to realize that these figures are actually real containers and we can get them to imagine turning them around. So right now I would usually get my students to imagine that this 40 cm and this 40 cm are actually connected. So we now have a separate, a different looking model or diagram whereby these two are actually joined together on the side of the 40. So you get actually one container with different heights. And we want them to imagine opening a floodgate here, allowing the water to flow into the tank B. What happens here is that the volume of water in tank A is the same. It remains fixed, but it flows into tank B. So actually they have a common base area, okay, of 1,800 plus 1,200 is actually 3,000 squared centimeters. So given the base area to be 3,000 squared centimeters, we just have to take the volume of water in tank A, which is 72,000, divided by 3,000, you will get 24 cm. So that will be the height of the water level in tank A in figure 2, which is when they are the same height. So as I mentioned, it is important for students to be flexible and to be able to see that there's a 40 and 40 here, and that water, when transferred over here, you can actually take the total base area, imagine them to be a same container, or the one container, the water flowing in to this container, eventually they will get the same height. And to find the height is just as easy as taking the volume from this tank divided by the base area here. And there you have it, how to solve a problem involving the topic of volume. So I hope this was helpful, and I'll see you guys tomorrow. Bye.